Good afternoon, ladies and gentlemen. Welcome for today's webinar. And we have a very encouraging participants. Over 450 have registered, and it seems that the subject is quite interesting. Just wanted to play some slides that we did on 31st May on fire door, understanding the standards and codes, and also we spoke about highest standard on fire door. Then we did on 10th July the facade and cladding. Very interesting topic that we covered on this. This is our third webinar. So this particular subject, probably the first time that we are talking, the critical role of fire-rated ducts. And to talk about today's topic, it's a very important topic, that fire-rated ducts. So these essential components are crucial for fire safety in our building. So once again, welcome everyone and thank you for joining us. So this may be the first time in India that we are discussing the importance of fire-rated ducts in a webinar titled Fire-Rated Smoke and Kitchen Ventilation Ducts. So do we really consider this in India while designing? So today we will explore the requirement, implementation. So how do you get assurance of the fire-rated product, testing and certification of these ducts? So today we have excellent expert speakers to share insight and discuss the challenges we face, as well as the advancement that can improve safety and compliance in our building. So let's start by understanding the current situation and determining where we need to direct our efforts to enhance building safety for everyone. So myself, my name is Dominic. So I come from almost 35 years of experience in the fire industry, and I've been founder of Fire and Security Association of India, FSAI, and also the founder member of Focus, which is a society which integrates all the building services together, and also founder member of NFE, National Federation of Engineers for Electrical Safety. So we've been hosting many webinars. Every week there are 1 or 2 webinars we've been doing. So with me I have my friend and colleague Mrinal Sapru, who is essentially the man behind all this webinar, getting connected with people. So he's been in India for a long time with over 18 years of experience as a client relationship management, business growth and innovative marketing. Recognized as a top sales expert with a proven ability to optimize efficiency. Skilled in B2B and B2C marketing, consistently exceeding revenue targets and capitalizing on the business opportunities. Known for strong problem solving, a robust work ethics and a reputation for reliability and sales integrity. So we have 2 important speakers, Daniel Wysokinski. I'll call him Daniel. So he's a principal testing engineer at Emirates Safety Laboratory, ESL, with over a decade of experience in fire testing across various industries, including civil and maritime sectors. Until 2021, Daniel was an active member of the European Committee for Standardization, CENTC 127, where he contributed to the development of fire-resistant testing standards. He also served on the National Technical Committee for Smoke and Heat Control System in Europe. In addition, he serves as a technical auditor for the European accreditation body focusing on fire laboratories. We have a second speaker for the day. So Mohammed Hassan is a mechanical engineer and certification specialist with Emirates Safety Lab. Over 15 years, he has specialized in smoke management and passive fire protection system. He is a certified fire protection specialist, CFPS, and also recognized by ASHRAE as certified HVAC designer and as per Green Building Business certification as a lead accredited personal certification BD+C. So with me, we have a wonderful speakers today. So I would like to welcome our Mrinal to do an opening remarks because he's based out of Dubai. So all Daniel and Mohammed also based out of Dubai. How do you think about India? So how important this to all the audience who've been listening to you, and how these other countries catching up with these fire-rated ducts and ventilation. So over to you, Mrinal.
Thank you, Dominic. Thank you for your kind words. So good afternoon, everyone, and welcome to today's session on navigating the fire testing and certification requirements for ducting systems. My name is Mrinal Sapru, as Dominic has already, told all of you, and I'm the regional sales lead here at ESL, based out of Dubai. I'm delighted to have the opportunity to be part of this session on behalf of ESL, along with my colleagues who will be speaking about the subject, as they are the subject matter experts. So you will learn, and I hope that you will take away key learnings from the sessions imparted by Daniel and Hassan. For those of you who are not familiar with ESL, I would just take a minute's time to explain what ESL is about. We are an internationally accredited third-party testing and certification body specializing in fire safety of construction products, and building materials. Our mission is to ensure a safer and more sustainable future by providing top-tier conformity services. We help businesses navigate the complex landscape of safety standards and market regulations. In fact, it is our goal to facilitate market access to global companies by providing conformity assessment activities and ensuring safety and compliance at the same time. As far as the Indian market is concerned, we are also closely working with authorities in India with the help of Dominic and his team, to streamline the process for manufacturers who are needing market access by helping them achieve their certification requirements in UAE and wider Middle East markets. Now, as we all know, the importance of HVAC systems in ensuring and both safety as well as comfort, because it's not only about safety, it's also growing awareness about the air being, air circulated by these systems to be cleaner. So comfort in these buildings. So all these areas cannot be overstated. When I say that, why I say that is because with the increasing complexity of modern constructions and the growing emphasis of energy efficiency, indoor quality management, it is very crucial that the HVAC systems meet stringent standards for performance, safety, and sustainability. Uh, in today's session, what we will do is we will explore the developments in HVAC testing and certification, with a particular focus on how these processes contribute to building safety and compliance with international standards. With when we look at India, we see India as a very fast growing market with lots of infrastructure and residential projects coming up across India, and even in the wider Indian subcontinent market. So it becomes onerous on us at ESL that that to be a trusted partner for all of you in this journey, so that we provide you with a comprehensive testing and certification services that enable our clients to meet and exceed the required standards. Our goal in this session is to provide you with the valuable insights into the current landscape of HVAC testing and certification, the challenges we face, and the opportunities which are there for innovation and growth in this vital industry. So, as we as we go through the entire session, I would encourage all of you to engage actively with our speakers, ask a lot of questions. There is a Q&A session at the end of their sessions. So please drop in your questions in that box. We will make every effort to ensure that your questions are answered, and share your experiences, because we learn from you. We learn from the experts like you, and we improve upon our deliverance to you based on your experiences. Together, we can ensure that the HVAC systems not only make make the whole only meet the standards, but they also exceed the standards in ensuring the safety. So I hand it over to my colleagues, Daniel and Hassan, starting with Daniel, to take the floor and deep dive into the technicalities of the standards. Over to you, Daniel.
Thank you.
Good afternoon, everyone. My name is Daniel Wysokiński, and I will take you through the process of testing process of the duct, which are called fire-rated duct. Let me share my screen so you will see the details. So today's topic is related to fire-rated duct. So what this term means? We will talk about the testing and product certification based on British standard 476 part 24 and EN approach. Um, So what we will discuss today? Today we will discuss the importance of the fire rating ducts. What are the types of the ducts? What does it mean, the fire rating of the fire rated ducts? If we are talking about the ducts only components, or maybe we need to consider the whole system, the duct assembly. We will discuss as well what is the best fire rated duct design. What are the fire exposure scenarios during the tests, the roadmap to the market for your duct, fire testing requirements based on those two families of the standard, and the criteria for successful testing, as well as the test results which you will use to the certification. I will shortly describe you also the classification of such duct based on two families of the standard. So when we are talking about the fire safety in the building, we cannot omit the smoke management system, because fire safety is directly linked to the smoke management system. And why is that? Because as you may know, the smoke inhalation is the major reason for the fire-related deaths. For example, the US Fire Administration specifies that around 75% of the civilian fire fatalities are caused by the smoke inhalation, compared to the other 25%, which are caused by direct burns or other fire-related injuries. When we are talking about the smoke management system, we can distinguish several parts of this system. What you can see is for the main part, which may be related to you, as you are, most of you are the manufacturer of the fire-rated duct. So one is, of course, the duct itself, and the second one is the smoke extraction fans, fire and smoke dampers, as well as the pressurized system. Today we will be focusing on the fire-rated ducts only. So in smoke management system, fire-rated duct serves several key functions. The first function is containment. They prevent the spread of the fire and smoke between the compartments, which is important in large building, for example, the high-rise building, where the failure of the duct may have the fatal consequences. The second is extraction, extraction of the smoke. So the fire-rated smoke extraction ducts are designed to actively remove smoke from the fire-affected areas, reducing the smoke the risk of the smoke inhalation, as well as improving the visibility and the process of evacuation. This is also very important for the whole firefighters' family teams to facilitate their job, their actions, and increase the safety of their job. When we are designing the building and the smoke management system, our first focus in terms of the fire safety is to facilitate, to make the evacuation process faster, safer. for the occupants. But we cannot also not focus on the safety of firefighters and what happened after the evacuation. So post-evacuation actions are also very important. The next function which are served by the fire-rated ducts is related to pressurized system, which is using these ducts to keep the smoke away from the escape routes, as for example stairways. And of course, ventilation, which is the main purpose of the duct, distributing the air across the building. The integration of fire-rated ducts within the smoke management system ensures that this system performs their role and their roles effectively under the extreme conditions of a fire. It is just not about the compliance of the duct in terms of the regulations, but it's also about creation a system that protects lives and works well. Therefore, we must remember that while designing the test specimen of the fire-rated of the duct which is submitted to the test in fire laboratory, it's not just to pass laboratory fire test, but to withstand the ultimate test, which is the real fire scenario. So when we have a fire-rated ducts, we can split them into three groups. The first one is fire ventilation ducts, then smoke extraction ducts, and the kitchen extraction ducts. If we will place them into the building, as you can see, the graphic which presents the ducts within the building, we can see that there is several scenarios. And this graphic represents example of the duct installation within the building, where you can see different types of the smoke extraction duct. As fire safety is related to compartmentation, we can distinguish these two types of the smoke extraction ducts as a multi and single compartment duct. This is, of course, as per European approach. This separation between the function of the smoke extraction duct is not present in BS approach. However, based on the test requirements and criteria and the conditions for the testing, we can assume that BS is talking only about the multi-compartment ducts, which serves multi-compartment, several compartments. The next very important aspects of fire safety related to the duct is kitchen extraction duct, which are installed in the commercially operated kitchens across the globe in all restaurants. Discussing the fire safety in the building, we just cannot omit these ducts in the commercial use, especially since some of the regions still using the ducts which are not fire rated or made of the materials which are not appropriate for this use, like aluminium duct. So what are the threats coming from this situation, especially when the duct is passing through several compartments? What can happen if there are non-fire rated ducts used in these commercial kitchens? Here we can see some statistics from 2023 only in US, Europe, Asia, and India itself, showing the fire incident occurring in kitchens. As you can see here, the common cause for all fires is the grease fire. These fire incidents are causing a lot of injuries, including fatalities, unfortunately, but also the aspect which is also quite important, economic loss, which is counting in millions of US dollars. So why these fires are happening is, as you can see here, the picture on the left side, maybe it's funny, but these represent situation which is in most of the touristic places visible, where the kitchen is making the flame really high, really wide, just to entertain their guests, the clients of the restaurants. Very often these flames are sucked in, pulled into the extraction system. And when the grease is accumulating inside the duct system, this is the good recipe for the fire, because during the operation of the kitchen in the commercial use, the extraction systems, inside the extraction system, the grease is accumulating. If the grease is big enough, and when this grease accumulation is exposed to the heat or direct flame, which are pulled into the system, the grease may catch fire and cause a lot of problem, a huge fatal consequences. If the duct is made from the wrong material, not fire rated, it may melt it. For example, if this is made from aluminium, and spread the fire to other parts of the kitchen or other part of the building, the restaurant, causing the total loss of the kitchen or even the whole restaurant. Sometimes even the whole building, the rest of part of the building may be affected if the fire protection is done not correctly. So what we can do, how we can avoid these kitchen fires? By frequent cleaning, frequent inspection, and a good maintenance of these systems. Having the fire rated duct also doesn't mean that you don't need to maintain the duct or the extraction system. You can see here the two tables. One is European approach and the other is NFPA guidelines. Both of them are based on the frequent maintenance, frequent inspection and cleaning, depend on the task or the volume of kitchen. So this is something which cannot be avoided, which cannot be missed. It has to be either manually, either monthly, quarterly, or even some tasks some guidelines are for the daily activities, daily task. We are talking about the fire-rated ducts. So, what does it mean? This rating? What stands behind these words? So, we have first of all the pillar called mechanical stability. These represent all structural stability of the duct itself. So for the duct, which is under the test, the duct inside the furnace and outside the furnace cannot collapse. The reduction of the cross-section area has to be within the stated limits, and the duct shall maintain its intended function. Also, for the smoke extraction duct, there shouldn't be any gaps developed on the duct surface, which are decreasing its capability for the smoke extraction. The second pillar is integrity, which represents effectiveness of the duct system to stop spreading the fire, either into the duct or either from the duct outside or through the duct penetration sealing system. Then we have insulation. Insulation is the ability of the duct system to prevent heat transfer, which means the temperature rise on the other side of the duct system. And of course, one of the most important aspects, which is sometimes missed, is smoke leakage. This is preventing or eliminating or limiting the smoke transfer through the duct system across the building area. Also, we need to remember that this rating is expressed in as a time in the minutes, representing, for example, 120 minutes or 240 minutes of the rating for such ducts. As I said, we are talking about duct systems. So what are the components of such duct system? It's obviously duct construction itself, right? How the duct is installed. What are the joints between the duct section, how they are sealed, what are the other factors related, suspension system and devices. Insulation system for insulating duct. All accessories which are within the duct system, compensator, access panel, and etc. Penetration sealing system. This is very important to understand. I would like to remember that penetration seal system belongs to the duct system itself. Installation, how the duct is installed or should be installed, instruction manuals, method of statement if applicable. And application. Application is means how and where this duct can be installed, if there is any application or whatsoever. So what should be the construction of a good fire-rated duct? Unfortunately, I cannot tell you the details because this is the know-how of each of you, but there are general things which are related to all fire-rated ducts. The duct can be made of steel, or it can be made of boards like calcium silicate type boards, which are also a good insulator, have a good insulation properties as well. So once we have a steel duct and we want to make this steel duct insulated duct, we need to put insulation system on it. We can define three types of the insulation. Either it will be in the spray form, or wrapping system, or as a board or slabs. If we are talking about the insulation system, we need to remember that this refers to the number of layers, thickness, density, and manufacture, because you are linked to these values, to these numbers, because you cannot decrease number of the layers, you cannot decrease thickness of insulation system, and you cannot decrease density of this system. The next thing is suspension system, which covers, for example, bearers, thread rods, anchors, and spacing. And one of the most important part, which some companies are forgetting about, is the penetration system. How your duct must be sealed when it's passing through the fire division, and this belongs to that system. Based on my previous discussion with the clients, I got information that this fire stopping is done by fire stopping companies, so they don't care about this, because this is done by separate companies, so they just want to pass the test and get the papers and make things done. So I can tell you this is wrong, totally wrong, because the penetration system belongs to the duct system itself. You cannot separate these two things from each other. Duct is also describing how it has to be sealed when it comes through the fire division. So you, as a manufacturer of the duct, you need to define how this penetration will be done, and this instruction of penetration and the way of this installation must be written either in the instruction or other documents and present to your clients. So we have three steps of product placement into the market, which is sampling, testing, and certification. Hassan will cover sampling and certification, and I will go you through this testing process. During the test, we are doing a test of fire resistant testing of the ducts under two scenarios: internal fire and external fire. Internal fire is simulating the situation where the fire is pulled into the duct system. However, as you can see on this graph, the duct is also exposed from outside. So we have external and we have internal fire. However, if we are talking about the multi-compartment duct, this fire can go through the second compartment. This is why This is called fire inside the duct, and the duct must contain the duct inside and not allow to spread to the other compartment, either through the duct construction or through the penetration seal system. On the bottom of this graphic, you can see the situation which is presenting single compartment duct, and the difference between those two is that the single compartment duct is removing the smoke directly outside the building and is serving only one compartment. External fire scenario means that the duct is passing through the fire through the compartment when the fire occurred. And this might be either ventilation duct or the smoke duct as well. For the smoke ducts, the fire in other areas cannot affect the efficiency of the smoke management system when they are already serving another compartment. So this is why also it's very important for the smoke duct as well. This is why leakage classification is also very important, either to include in addition or to have it in the classification code, because this provides some provisions to eliminate or to limit spreading the smoke through the building. So what are the roadmap for the duct tested as per BS and EN? If we are talking about the BS, we have BS 476 part 24 from 1987. We are doing the testing, and as a laboratory, we are issuing the test report, which goes to the next step, which is assessment report. The assessment report is based on the rules or guidelines for assessment, which are not on the international standard level. And this is good to highlight that during the assessment report, we need to be very careful, because you need to remember that most of the cases we are doing the test of the duct, which having the width of 1 meter, the height of 250 millimeter. So giving the assessment for the size equal to, for example, let's say 10 meters by 10 meters is quite dangerous. So this is why it must be done in very with all responsibility for the authorities which are preparing this assessment report. At the end of the road is also certificate, which is done by the certification body. For EN ducts, EN approach, the road is looking a little bit different and having 2 lanes. The one lane is for the ventilation and kitchen ducts, test as per EN 1366-1. We are doing the test, we are issuing the test report, which having the direct field of application of the test results. This is something unique for EN. After that, you can use the standardized rules for assessment or changing some parameters across the duct construction, which is which is end up with the EXAP report, and then those 2 types of the reports are combined by the classification report, giving you the wide of the combined application as well as a rating in terms of the classes. If we are talking, and then there is a certificate. If you are talking about the smoke extraction ducts, we have 2 standards, part 8 or part 9, depending if we are talking about multi or single compartment ducts. Then there is also classification, but with different part, different standard, and then certificate as well. So what are the requirements for the BS 476 part 24? So first of all, let's talk about the conditions inside the furnace. BS standard is referring to ISO 834 as a standard time temperature curve inside the furnace, which after 90 minutes is reaching 1000 degrees or above. I had several questions regarding the low temperature fire rated ducts, which are tested under 400 degrees. Is it possible? Is it allowed, or it's maybe not appropriate, or maybe not in line with the standard? So it's not really in line with the standard, and this is why, because the scope of BS 476 part 24 is to horizontal and vertical duct, which are tested under standardized fire conditions, which are referred to ISO 834. So based on the BS 476 part 24, it's not in line. As per EUA Life Safety Code, it's not possible to get it to get this kind of duct. However, I will give you a hint how you can get so-called low temperature fire-rated duct if they are tested as per EN. If we are talking about the conditions for the duct itself, so we have duct A and duct B. Duct A has a branch and is fully sealed inside the furnace. We are keeping under pressure, we are making under pressure of 300 Pascal inside the duct at the beginning of the test, and then we are not changing the fan, the speed of the fan throughout the test. For duct B, we are setting 3 meter per second of velocity at the beginning of the duct, and then the same scenario, we are not changing the speed of the fan. The test is having two situations: fan on, which is the majority of the major part of the fire testing, and the fan off situation. The fan off situation is repeating every 10 minutes before each 30 minutes of the classification time. So for example, 20 minutes after the start of the test or 50 minutes after start of the test. The fan off situation is simulated by stopping the fan and for 5 minutes, during which we are assessing the integrity. So what are the requirements for you to create the duct for the testing? You have the limits, you have the minimum numbers of the length and the size of the duct for horizontal, which is a minimum 3 meter long inside the furnace and at least 2.5 meter long outside the furnace. The cross section is referred as a rating 1 to 4 in the 4 to 1 width to the height. So mostly we are testing 1 meter width of the duct and 250 millimeter of the height. Duct A has a branch, as I said. The branch has the same cross section as the main duct. The duct B is having the opening, which is located inside the furnace, half a meter from the end of the duct. And as you can see, the highlighted informations, one of these highlighted information is the fire stopping, which should be as in practice during the installation. We are talking here about the minimum length of the duct, so we can extend. And the BS is telling that if we can test longer duct, that this is the most desirable situation. For vertical ducts, it's quite similar scenario. Beside that, duct A can have no branch. BS 476 part 24 is referring only to the duct assembly. It's not describing the accessories of the duct system. However, we can do the test of this duct, but as a part of the assembly, as a part of the duct system. The accessories cannot be assessed separately from the duct. So where these accessories shall be located? In terms of the duct A, we have these accessories inside the furnace. For duct B, those accessories shall be located outside the furnace to assess all criteria. And you need to remember that we are talking about the fire duct and accessories to fire duct. The VCD, volume control damper, cannot be a fire damper because fire dampers shall be tested in a separate test, under different test standard. You can choose, for example, EN 1366 part 2 to test the fire-rated dampers. What are the criteria for the ducts, ventilation, smoke, and kitchen ducts as per BS 476 part 24? We have three main criteria which are described in the standard: stability, integrity, and insulation. Why the next two criteria, reduction of the cross section and the temperature of the kitchen extract duct, are presented in a different way. This is why, because the standard in clause 1.5 in the scope of the standard is telling us that the international standard is not appropriate for the following ducts unless the further criteria described in the annex are established to satisfy the appropriate authority. So if authority will accept this, you can use this annex to establish the criteria. So duct A needs to follow all of these criteria, and duct B will only needs only fulfill 4 of them: insulation, integrity, stability, and cross-section reduction. If the duct system contains also the accessories, you need to remember that to achieve positive test results for a duct system, all accessories within the duct must fulfill the same criteria as a duct, because we are assessing the duct system, not individual components of it. So for assessment of the insulation, we are using the temperature measurements on the unexposed side of the duct. BS is describing 8 thermocouples as a minimum, 4 thermocouples, 1 on each side, 50 millimeter away from the wall, and then 1 meter away from the wall. The insulation criteria is either average or maximum. Average is 140 degrees rise, and maximum is 180 degrees rise. This is rise, not the actual temperature. This is rise, not the absolute temperature. Means, for example, if the initial temperature is 20 degrees, 20 plus 180 means 200 degrees of absolute temperature. However, the average rise of the criteria is calculated based on the thermocouples which are placed on the normal thickness of the duct. For example, if the first 4 thermocouples are placed on some additional protection of the fire stopping system, only the next 4 thermocouples are counting to the average. As a laboratory, we have the right to put additional thermocouples if we can identify the hotspot, the risk for the insulation criteria. The air thermocouples, which are presented as number 1, as number 2, is only for your information or certification information. This is how the test results are presented, as how they are presented. So you can see that integrity and insulation has the same test results, even though that insulation was not failed. But this is because of the regulation of PS 476 Part 20, where there is information that insulation is also failed once the integrity is failed. If we are talking about the YEN standard, we have 2 conditions inside the furnace. We have the same conditions as BS for ventilation, kitchen, and multi-compartment duct. Plus, we have lower temperature for the single compartment duct, and this is your legal point to get low temperature fire-rated duct to be classified and certified. But this will be limited to the single compartment smoke extraction duct, which serves only one compartment. This is just to remind you how it looks like the single and multi-compartment ducts in the building. The requirements for duct A and duct B is quite similar in the difference that we are maintaining pressure in duct A and the velocity in duct B. For duct A, there is also one more requirement, that if this duct is intended to be used as a smoke extraction duct during the test in accordance with Part 8, the pressure must be increased to 500. The same scenario for fan off and fan on situation, but there is a different repeating time, only 5 minutes before each 30 minutes of classification. In terms of the construction, the standard defining not the ratio of the sides, but the proper dimensions. For duct A and duct B, the dimensions are different. The width is the same, but the height for duct A is 0.5 meter. For duct B is the same as BS. What is the other difference is that branch of duct A is with the smaller cross section. For BS was the same as the main duct. Here you have only 250 millimeter of cross section. EN is also defining the position for the access panel within the standard text. So it's describing accessories of the duct system and where these accessories must be placed within the duct, and also is telling that the same thing, that the fire stopping shall be as in practice with the maximum gap between the duct and the wall. What is unique in this standard is that EN 1366-1 and part 8 and 9 is defining standard supporting construction and the non-standard supporting construction. Standard supporting construction is defined in these three tables, and it's giving you some opportunities. For example, if you will choose to install your duct to test your duct passing through the flexible supporting construction, you will get in the field of application the possibility, and you will be granted allowed to install your duct on the site within the drywall system, AC blocks or concrete. However, if you will do differently, you will do the test in concrete wall, you will not get AAC and flexible. So this is something which is unique for EN standard. However, if there is a project-based separation and the specific design, which is not listed as a standard supporting construction, you need to, if you test this duct with passing through this specific wall, you are linked to this specific wall. So here we can see the comparison and the summary of the classification criteria for EN duct. And what you can see is that EN is providing additional type of duct, which is duct C. This duct type C represent smoke extraction duct, which are tested either as per part 8 or part 9, depending on the end-use application. What is also important to notice, and very important for you as a manufacturer, that the EN standard is focusing very much on the leakage of these ducts, because as you can see, leakage is not only the separate classification, which you can get or you cannot, or you don't need to, but also is used to assess integrity. If you exceed a certain limit of the leakage, you just fail the integrity, which means the whole duct is failing the test. European standard is also focusing more and precisely describing how the temperature criteria, the insulation, shall be assessed, providing information where this thermocouple should be placed, in which distance from the wall, and presenting some example of fire stopping design and how to deal with this design with the thermocouples. Also, the European standard is prescribing precisely where to put thermocouples inside the furnace, inside the duct A, to assess kitchen extract duct. BS is just telling us that we need to measure the temperature if you want to get the kitchen extract duct, and this temperature cannot exceed the limits. However, they are not. BS is not stating where and how to put. EN is telling us where to put exactly, how to put thermocouples, and is providing much more details. However, for BS and EN, kitchen extract duct must be can be assessed only during the duct A. You cannot get the classification for and the certificate for the kitchen extract duct having only duct B test, because there is no thermocouples inside the duct for assessment of the kitchen extract duct. European standard is also providing details how to assess the accessories. For example, here you can see the access panel and the placement of the thermocouples to assess insulation of access panels. You also need to remember that insulation measurements shall be done on each accessories which are part of the duct system. Access panel, some VCD damper, sound attenuator, or compensator The summary of the test result looks quite similar. There's also the same rule for integrity relation to the insulation, where integrity fails, the performance of insulation should be automatically be assumed as not satisfied. Plus is also stating the performance criteria for the leakage. If we are talking about the smoke extraction fans, extraction ducts, either multi or single compartment, we basically talking about the same construction. The length of the duct inside the furnace should be at least 3 meters. Outside the furnace, at least 4.25. Why there is 0.25? Because 250 millimeter away from the wall, we need to place the perforated plate, which help us to make under pressure inside the duct. Because duct C construction is quite similar to duct B, and table 1, which is presented here, is showing you the pressure levels which you need to choose before we start testing. So most of the clients are using pressure level number 3, which is giving you the widest scope of application for your duct, which means under the ambient temperature, the leakage of the duct is measured when we are making 1500 pascals of under pressure inside the duct, and during the fire test we are using 500 pascals inside the duct. So why there is 2 meters per second of criteria? Because this 2 meters per second is related to the perforated plate. First, we need to calibrate as a laboratory perforated plate. If this is correct, you as a manufacturer, you are fixing this plate within your duct. And then we are doing the leakage test. After leakage test is having the positive result, we are proceeding with the fire testing. And this is, as you can see, the construction of duct C is quite similar to duct B. So you can start wondering, so how we can assess the leakage of these duct C. So when we have the opening in the furnace or within the construction of the duct. So basically we are assessing the leakage based on the oxygen measurement, which are done before the perforated plate, which are, and this is G1, and within the flow measuring station. So based on these measurements, we are doing the calculations to assess the leakage of the duct system. And the standard is also providing some example how we can assemble the perforated plate within your duct, depending if this is the steel or the board type system. Ian is also putting some focus on the conditioning of the fire stopping, because if you are using the either water-based sealing material or hygroscopic sealing material, and these gap exceed a certain limit, either 25 or 10 millimeters, you need to be aware that this will affect on your plan for testing, because the curing time which is requested by the standard, maybe even 28 days. So at the end of the testing, in the test report, you will get something which is called DIAP, the field of direct application of the test results. So what is it? The field of direct application of the test results defines all available changes to the specimen following a successful fire resistance tests. This variation of the construction can be applied automatically without any further assessment calculation or seeking approval from a certification body, because this is something which you can do without asking anyone for permission. So what this field of application refers to? It of course refers to the duct orientation, to the size, height of vertical ducts, the pressure differential, suspension devices supporting construction, as I described you before, fire stopping, and accessories. The size of the duct can be increased by using the EXAP standard 15882 part 1. This is only for the ventilation fire-rated ducts. So if we need to compare these two families of test methods, BS and EN, you can see that BS is referring to two types of the duct, duct A and duct B, where EN is introducing the third type of the duct, duct C. In terms of the criteria, BS is not defining the criteria for the leakage. However, the BS 476 part 24 is mentioning in the text that it may be measured, but it is not mandatory, and there is no criteria established for such measurement. There is also no criteria if we are talking about the duct A, where we are making the under pressure of 300 pascals. We are, as a laboratory, we are obligated to report as a graph the pressure in the duct A. However, if this duct A will start losing the air tightness and the under pressure will start dropping down, there is no criteria to say the failure of the duct. Whereas the EN is clearly mentioning this criteria for the leakage, either if you want to have a additional classification mark S for the smoke leakage, or it's mentioning in the integrity criteria as one of the criteria for the integrity for the ventilation duct, kitchen duct, and the smoke ducts. The construction of the duct for the testing is quite similar. However, as I said before, there is a difference between the size of the duct A and its branch, plus EN is more precise in terms of the insulation criteria where to put thermocouples. So how these tests are done in our laboratory? We are using this furnace, which is combo furnace. It's made from two chambers. The length of our chamber is 4.5 meter, but if the client wants to assess a lot of accessories, we can combine those two chambers to get around 10 meter long furnace. So how these ducts are installed inside and outside the furnace? Inside the furnace, they are suspended by the intended devices, and these devices are fixed to the concrete slab. Outside the furnace, the concrete slab is simulated by the steel construction, but the suspension devices shall be the same as inside the furnace. For the measurements of the flow and leakage, we are using the orifice plate or the nozzles. And in terms of the nozzle, I can give you a fun fact that this is like a small NASA construction in the fire laboratory, because the accuracy for these nozzles is 0.0108 millimeters. So it's quite a precise device. Why we need to do the test of the ducts to confirm that this duct design is okay to call it as a fire-rated duct, because inappropriate suspension devices may result in collapsing of the duct inside the furnace, or the wrong design of the duct may result in collapsing the cross section, which stops, makes duct no longer fulfill the intended function, and the duct cannot extract the smoke from the furnace. In terms of the fire rating, for the BS, we have quite simple rating. We have just 120-minute rated BS 476 part 24 duct, which stands for stability, integrity, and insulation. However, insulation must be mentioned together with the rating that either this is insulated or uninsulated duct. In terms of EN duct, EN are classified as per 13501-3 for the ventilation duct, and the rating is defined as a classification code, as you can see here, where E stands for integrity, I for insulation, where S for the smoke leakage. The numbers are classification period, which is rating in minutes. VEHO is defined as a orientation, vertical or horizontal, and the last aspect is defined as a fire scenario. The smoke extraction duct classification looks very similar, but in terms of the orientation, instead of orientation, you have to other factors: operating differential pressure at ambient temperature, and the suffix multi or single, which stands for either multi-compartment use or single compartment use. Also, there is a difference between EI or a multi and single compartment, because the E, there is no I, there is only E600, which means that this duct is for the single compartment test under 600 degrees. And that's all from my side. Thank you very much. If you have any question to the testing side, please write this or in the comment, and we will try to answer these questions. Thank you very
Okay,
much.
thank you. Thank you, Daniel. It's almost 1 hour. Uh, Asan, can you take the floor and take it forward from here?
Yes, yeah. Thank you, Dominique. I will just share my screen.
We have almost 21 questions, Daniel, for you. While Hassan doing, maybe if possible, we can probably answer those questions on the Q&A box that you could see from. We also have, if people wants to ask few questions to you directly. So once Hassan is complete, so we can probably have online, we can probably talk to them. So those who are interested to talk to Daniel or Mohammed Hassan, please raise your hand, and I will take you live once the session is over, and also we attend these questions. Some of the select question we can take it forward and do that.
Okay, I believe now my screen is shared. Yeah, okay. Hello everyone, thank you for joining today. I'm Muhammad Hassan, the certification specialist at ESL, Emirates Safety Laboratory. In this is part of the session, we'll be discussing regarding the fire rated ductwork system assessment and certification based on BS also an EN approach. And the discussion point.
The screen is not. Sorry to interrupt, Mohammed. The screen is not
Yes.
seen. Can you share the screen, please?
Okay. Let me just try it again.
Yeah, the presentation still not come on that. We can see your your laptop, but
okay. Sure.
yeah, if Daniel is around, yeah, no, it is your laptop.
Now, yeah, let me just again reshare it the screen. Yeah. Okay.
Yeah, perfect. We can make it full.
Yeah. Hold on.
Nice.
Yes. Okay. So the coming to the point, what we'll be discussing in this is part of the session.
Screen is still not full, Hassan.
Yeah, it is not full screen. Actually, it is showing me yes, it is full.
No, here I can see the slides.
Okay.
Yeah, perfect. Go ahead.
Now it's okay?
Yeah, perfect.
Okay. 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 So firstly, we will be going through the primary category of the ductwork, and also why the fare-rated ductwork system it is required and necessary. and also the category of the fire rated ductwork itself. Will be touching the ventilation ducts, also touching extract ducts, as well as smoke control ducts. The smoke control and management system concept also will be discussing regarding the same point, and also the ductwork system component, what the component of the ductwork, and building code and regulations related to the targeted area in the world, and also testing standard. I believe already Daniel he covered the full details about the testing. Just only will be highlighting the requirement of the input, which it will be help in the creating the certificate, and the fair scenario also, what assessed fair scenario, and the importance of the third party certifications, why we need to have a certification, and how to select and produce the right product to the market, how to get your ductwork system certified, also the way of how you can certify the product, the ductwork system. And also we'll be discussing the ESL certification journey, how we certifying the ductwork system in ESL as a sample, and also the ductwork labeling and certification mark and user certification mark. This is a topic what we'll be discussing today. So primary category of the ductwork, nominally we can find in the most building there is a fresh and exhaust ductwork, which we call it as a ventilation. And specifically for this is point I want just to highlight it, there is a connection between ventilation as a fire rated ducts, and also ventilation here as a air distributor, normal air distribution in the building, and also for heating and cooling, and as well as smoke control. We'll be going through definition of all this is three category of the ductwork. But anyhow, the ventilation, what it means here, it is only related to the human ventilation, which is the fresh air and also the exhaust air. But the ventilation term in the related to the fair property, it is connected to the both system, which it is cover this system and this is system as well. Why the fair rated ductwork system it is required? Basically, we have the ductwork which it will be crossing through multi-compartmentation inside the building, and to protect this is fair zone, if we may call it like that. We need to protect this is fair rated duct, so to not spread the fire from origin place of the fair to the other zone. And also in some scenarios we require to have a rigid duct which it can be performed during the fair incidents, same like in hospitals and all this is applications. So in that scenario also we need to have an rigid system, which is it will be compatible compatible to work during the fair. And also obviously smoke control and management system, it need to be worked during also the fair. That's why we required the system to be as a fair rated ductwork system. Fair rated ductwork category. So we have three category for the fair rated ductwork, which ventilation. For ventilation, as I explained it, the ventilation here, it means all the system, all HVAC system, which it mean fresh air, exhaust, heating, cooling, all this is applications. It is coming under the ventilation for the perspective of the fire-rated ductwork. This is duct serve a heating, ventilation, and air conditioning system duct, and they are required to be assessed against fire-resistant performance when the design involve HVAC system running during a fire. For example, same what we said for hospital or healthcare building. And we have also kitchen extract. Actually, this is kind of duct. It is crucial, and it need to have attentions because firstly, the nature of the work of the duct itself, it is working under difficult condition or under difficult hot area, and also at the same time it is containing the duct itself, it is containing combustible material, which that's why there is in a lot of building codes and regulation we can see there is a clear instruction and also limitation for this is kind of duct. And also we have the smoke control duct, which it is serving the smoke control and management system during the fair. Okay, coming to highlight more in the smoke control management system, just on the general concept of the smoke. The smoke, it's same Daniel he explaining. The smoke, it is contributing to the cases of the deaths in the fire by big values, same like 75% of the deaths in the fire occurred because of the smoke. So that's why we have a separate or a specific system just to target and to deal with the smoke. In the general concept, the smoke control, it is utilizing the pressure difference to control the smoke movement. And when to come to the next level, the smoke management concept, it is utilizing natural and or mechanical system to maintain a tenable environmental in the means of the egress and control and reduce the migrations of smoke between the fire area and communicating space. That means we will be utilizing all the strategy, smoke control strategy, together to have it as the smoke management system. So the smoke management system has a lot of components. We have a fans, we have dampers, and also smoke curtain. All this is parts of the system. It's work together to just to control and to enhance also the smoke during the fair. And today we are focusing in the fair rated duct, and as I explained it before, the fair rated duct is crucial and essential also to be targeted because this is a component it's connecting all the all the smoke control system, and also it is going through multi-compartmentation. So any failure in this is part of the system, that's mean the full system probably it will be failed. Okay, so the component of the ductwork system, normally we have the ductwork itself, that's is including the metal sheet, gasket, sealant, and fixing components, and like rivet, all this is component. And also we have very important part of the system, which is penetration seal, just to protect the passing through the building elements, same like when the duct is passing through the wall, partitions, roof, the floor, we need to protect the passing through. This is this is or the penetration of this is elements to not let the fire either to spread from one fire zone to the another. So that's why the penetration seal, it is part of the system which it will be assessed during the test. And protection layer, we have coating or either we have the insulation just to protect the ductwork, and we have also the supporting system to support the system installation, either horizontal or vertically. And we have also some ancillary items, same like we have sound attenuator, we have the VCD. All this is sound attenuator, it may be installed with the system. Coming to the building code and regulations, this is actually depending on the area where we are targeting to use the product or to sell the product. So specifying the application in the building code, we are specifying the application and minimum fair performance requirement of the duct system in the building. This is rules, it is coming directly from the building code, and the specified duct fair performance requirement as per the building fair performance strategy and scenario, which it is set by the AHEG. So we have some, like in India we have a national building code, we have in UAE Fair and Life Safety Code. UK, we have the document approved document B, and we have IBC in US. So all this is kind of building code and regulations just to control and to enhance the use of the fair rated ducts. So ductwork application code and guideline, we have supporting the building code. Also, we have many standards and code and guidelines just to support the application of the product, and also the design, starting from design, manufacturing, as well as the installation. We come same like NFPA 90A, and we have also NFPA 92, NFPA 96. All this is a standard just to support the design and installation and manufacturing and installation of the product. We have also BS, which is it is supporting how practically it can, BS 999, which is supporting how practically it can be used, the building component it can be used. And also we have DW 114 and Smagna, both of them. Both of this is a standard. It's just supporting the manufacturing or design and manufacturing of the product. And ASFB Blue Book also, this it is bring some basic understanding of the for field of application for the this is product. Fair testing standard for ductwork. Actually, this is, we can say, testing and classification and product standard also. For today's session, we are focusing in BS. So we have 476/24 standard, and also for EN, we have 1366 part 1, we have 1366 part 8, and part 9. I believe Daniel already explained in detail. All this is standard, but basically we have 24 BS 476/24, which it is including all type of the three product what we explained it. It's ventilations as a kitchen extract, and also the smoke control duct. It is coming under one standard. We have for EN part 1, it is only targeting ventilation, and for ventilation for EN, it is including ventilation and kitchen extract together. And for smoke control, it is coming either under part 8 or part 9. Part 8 it will be for multi-compartment. Part 9 it will be for single compartment. We have the classification, the result, what it will come from. This is 3 standard for EN. It need to have classification just to standardize the rating, what it will come from the test result. That's why for EN approach, there is a classification standard to standardize the rating. So we have 13501 part 3. This is for ventilation duct, which is coming from part 1. And also we have EN 13501 part 4, and this is for the smoke control classification for the smoke control ducts. For EN 12101 part 7, this is a product standard. Actually, this is just to harmonize the product in the Europe market. That's why they call it product standards. And we have EN 158821 part 1, which is a XABI standard, and I believe also Daniel he touched. This is a standard just to extend field of application of the ventilation duct. And when we will discuss the certification step, also we can come back again to the same standard. There is another standard far away from the BS and EN standard. We have ASTM standard also for ventilations and also for the kitchen extract. This is another standard, just only it is some economic. It is working with this standard, and the other economic is working with the EN standard. As far as the concern of UAE here, it is almost many standard of this. It is recognized also in the local market, and we have also ISO for ventilation as well as for kitchen extract. And we can note here also the for kitchen extract, since this is application, it is crucial as explained it. We can see there is a specific standard which is targeting only the grace duct or the kitchen extract ducts. We have also UL standard as well and as FM standard, but FM it is different concept. It is not coming under the same category of the smoke control ducts, and but they have different categorization for the ductwork. Okay. This is test result, same like Daniel wrote, he explaining just to what we can get from the test to have it as an input for the certification. We have the mechanical stability, and it will come under the stability criteria. We have the integrity criteria, and also we have the insulation criteria. This is for BS. For EN, we will be also having, in addition, a smoke leakage criteria. And all this is rating, it will be mention it as a minutes for the BS, but for EN, it will be classified through the classification standard, and after that, it will have a rating. Testing fair scenario, basically, because who is dealing with this system, they will be hearing a lot about duct type A, duct type B, or duct type C. So just the basic idea of this is one, it is the fair scenario. When we are trying when the standard is trying to prove the applicability of the system, ductwork system, the test it will be just to see two fair scenario when the fair is generating in the with the duct have opening or without duct have opening. So for fair attack from outside of the ductwork, we call it as a duct type A. We're trying to protect the fair not to penetrate inside the duct, to spread the fire to the other compartmentation. Same like this is compartmentation. And for duct type B, it will be the opposite. We already have the fire is generating in the compartmentation, which it is have some opening, which is have opening, and the fire is already penetrated inside the duct. But we are trying also to protect the other zones from spreading the fire or penetrating the fire from inside to outside of the duct. And normally we call it, for both standards, they're using the same term, duct type B. For EN standard, they introduce a new concept, if we may say that. It is fair because the smoke control duct, originally, it need to work under two fair scenarios. So one duct itself, it may be come under scenario of duct type A or duct type B. And to check and verify this is point, there is a test or type of duct, which is called duct type C. In this scenario, we can see they are trying to prove the duct it will be work and it can perform under the two fair scenario, fair from outside and the fair from inside. Now coming to the point of important of third party certification. Generally, what the question it will be why we need to have a certification. I already test my product. I already passed the test. So why I do need to have a certification or third party certification? To prove what? So to ensure the compliance with regularity and stationary requirement, to facilitate also the access to the market, to provide end user with the assurance by meeting specific project requirement, and also to enhance operation effectiveness through improving process, supervise the product compliance continuously, and ensuring traceability of the manufacturing product. What this is mean? This means you will be having and trust and quality product to the market. And also the third party who normally performing the certification procedure, when it will be accredited certification body, that is mean it will assure to you as a manufacturer the level, certain level of compliance, and they will be having certain level of quality also to perform the work. Same like ESL, we already accredited to ISO 17065, which is normally the standard for global standard for the certification body. So that benefit, what I explain it now, just only from the market view of it, but also from practical view of the product. This is product, why we need to have a certification and assessment. Because actually when you will be testing in the furnace, what you will be testing in the furnace, you will be tested only 1 meter by 25 millimeters duct size. So normally, practically, you need to have a various size, you need to have a various materials, you cannot stick with. So to have an options to give you, to assess all this is big family of the product, you need to have a certification. So to prove to the end user or your client, this is system or ductwork system, it is capable to perform under different conditions. You need to have a certification proving that by assessment for duct type, for duct with tested BS 476 par 24, and also using extended field of application for ventilation duct for EN standard by using 15882 part 1. This is step it will help you also to extend. We can see here, you can extend the various size material sheets. Normally it will be tested with one material sheet, something like galvanized steel. You will be having the options for mild steel, stainless steel, the supporting system, because you need also to have a various supporting system size to accommodate the different in the ductwork sizes, supporting construction, same like Daniel what he explained it, the type of the supporting constructions, and also the sheet metal orientation, gasket, and ancillary item, penetration seal, insulations, and also the fixing system. All this is a component of the system. All this is details of the system. It need to have assessed and to see the limitation, and also it need also to be assessed carefully, not to extend something out of practice, or to limit it also to something not to be practically applicable. Ductwork system market growth. Recently, the ductwork market actually it is getting attention, and also it is started to grow as well. And according to the statistic, uh, in 2020, the global fair rated duct market size was reported to be 2,221.1 million, and Fortune Business Insights project grows from 2,280.3 million in 2021 to 3,165.3 million in 2028. That means it will be a CAGR rate of 4.8. Okay, select and product the right product. Select and produce the right product for the market. To select the right product, we need to understand the selected standard. What standard it will be selected, and we need to see the end use of the to understand also the end use of the building applications, targeted classification according to the building regulations, and also the accreditation requirement. All this point, it will be discussed before even starting the project, just to understand what's the scope of the work normally, and to try to accommodate as much as the requirement of the client. How to get your ductwork system certified? I will take our example by our certification body as Emirates Safety Laboratory, and we have a product, and you are trying to get a certificate for your ductwork system. So we have a certification requirement, and for certification requirement we have two parts: the product requirement, which it is presenting your requirement as the manufacturer, and the certification process requirement, which it's presenting the requirement to get certified as a certificate from our side as a certification body. For the product requirement, this is normally coming from either from your targeted market and your building regulations, and for example, in UAE Fair Life Safety Code, the local requirement in the UAE, and also in Chapter 10, we can find all the requirement for the smoke control system in the code. Also, we can see here there is a specific requirement for the system, what's the requirement for the smoke control system, and also what's the applicable standard recognized by the code. And for the other side, also the certification process requirement, what the steps we know normally or we require to doing to certify your product. So we starting from the request, your applications, and after that, we will be having review and evaluation plan. We will be having testing, and in parallel, also we will be having initial factory audit. After that, after the result of the test and the result of the factory audit, we will be having the decision arriving to the certificate issue. And in some economic or some countries, you may require the authority approval, same like in UAE here, we require to have an approval from civil defense, target to civil defense. So the ESL certification journey actually starting from the application, when we will be discussing the your requirement and how it will be how it can be satisfied, and also we will be offering the quotations to the client. And after that, after accepting the quotation, we will be having the project kickoff, and we'll be starting sampling. We will be sampling the test specimen from the manufacturing location, and also we'll be performing the fair test for duct and factory audit in also the factory locations, and we'll be having the technical review for all the input from test and as well as factory audit. The issue, and after that will come the issue of the certificate. And coming to the point of ductwork labeling or use certification mark, actually for this is kind of the product for ductwork system, it is not necessary or mandatory to have an labeling because of the nature of the product itself, but there is an option also to use ESL or to use a certification mark. For us, it will be ESL mark. It will come with your design for the ESL mark to be performed after installation of completed after completing the installation of the system, complete system. And also for some other product, or if the client requests, we can produce the labeling. And for the labeling also, it will come, it cannot be installed in the product unless the complete system it is happen and finalized. Because actually there is some practice we notice in the market, the application of the certification mark and the labeling, it will be done in the factory itself, which is it is against the certification which it will be issued to the manufacturer, or it is issued to the manufacturer. This is label or certification mark, it need to be applied after finalizing or completing the installation of this full system. That is, it will be all, and thank you.
Okay, Hassan, we will take a few questions that we have uh, for both Daniel and the thing. So I'll just read out. Still, we have a good attendees. Still continue to listen to this session. JJ Spark is asking Daniel, what are the key consideration for ensuring that smoke ventilation promptly activate in the event of fire? Daniel, are you there? Can you
Yep,
unmute?
can you hear me?
Yeah.
Yeah, so in terms of the smoke leakage, it's quite, I mean, it depends on what kind of scenic material you are using. Are they, this is intermittent sear or intermittent sealant? But no matter what type of the material we are using, this performance must be tested during the test to provide evidence. So the key performance is the type of the material which you are using. You need to use the proper materials to the proper purpose of the duct, and design of duct itself has to be the same proper. The proper means you need to define the proper, having in the mind that it must be airtight as much as it possible.
Okay, I'll next question because we have a lot of questions, so we can be brief. Tejas Singh is asking: generally, duct air velocity are range between 7 to 8 ms pressure inside up to 1,500 pascals. How to test and certify it? Please give your thoughts.
So if we are talking about testing, we are testing under standard conditions where during the test we have 2 meters per second. In terms of the pressure, for the EN duct, you have the defined levels in part 8 or part 9, and you can choose 1,500 pascals of under pressure, which is tested during under ambient conditions. During fire conditions, this is tested as per 500 Pascal. As a direct field application, you will get from 1,500 negative to 500 positive. I believe, Hassan, you can also tell us something about this answer to answer this question from the perspective of the certification. What will
Yeah.
be included in the certificate?
Yeah, I believe he is talking about the pressure. Again, is the classification of the leakage for the ventilation purpose. But anyhow, for EN, it is there is an option to increase until 1,500 pressure, just to satisfy this requirement. As far as the concern of BS, there is no clarity from the term of the test itself, just to specify more pressure requirement than is specified in the standard.
Okay, moving to Satish Vincent is asking: as a manufacturer of insulation, let's say stone wool, do have opportunity to supply to any system as long as I meet the density, thickness, and layer that was used in the tested systems.
Hassan, you can reply because I believe this is related to the certification.
Sorry, just as the sound it was not clear. Again, what?
As a manufacturer of insulation, let's say stone wool, do I have opportunities to supply to any system as long as I meet the density, thickness, layer that was used in the tested system?
I understand. Yeah, the idea actually for the testing and certification, to ensure the system capability to perform same what it being tested. So to assume one kind of insulations which it's tested with a specific ductwork constructions, it can comply with all the other ductwork construction is not true, and also it's not as per the standard requirement. So it need to be tested with the targeted construction ductwork construction system.
Okay. So Naji Hisham is asking: KD is carrying fire and smoke from kitchen, essentially type B duct. However, the testing is done only for the type A duct. How is this effective?
So basically, to get a kitchen duct, you need to do the test of duct A. Without having test of duct A or duct B, you cannot get classification for the fire inside or fire outside the duct. However, as per EN, for example, you can get, as I presented on the last few slides, the different classification for only duct A or only duct B. However, you will be limited to the application of this duct. That, for example, you have an application only classification only for duct B. So your application is only fire inside the duct. You cannot use this duct as a kitchen or as a duct A. Hassan, you can add more points from your side.
Yes, also the same. Actually, I believe the kitchen extract is need to have some like special treatment because if we will come to the basic idea of the kitchen extract itself, it is single duct, which is it is fell under the two fire scenario. So the idea of adding the thermocouple inside the duct surface just to assess when there is a accumulated grease inside the duct itself, and there is a and the nature of the duct itself is working under high temperature, so not to easily ignite the grease inside the duct and spread the fire in the other compartmentation. That is why I'm seeing the idea of selecting duct type A or duct type B, which one it should be represent or present the kitchen extract. It is depending on which one is where's that is the limitation to the kitchen extract, since you cannot separate or you will not be able to separate one scenario from the other. So the weakest one, it should be marking the kitchen extract duct rating.
Okay, thank you, Hassan. Saeed is asking, while testing the duct to DW144, is is there any specific criteria considered for support system?
So maybe I will answer from the testing point of view. BS and EN doesn't refer to these standards, and the supporting systems during these tests, either under BS under or EN requirements, is limited to what was tested. However, if you have supportive documents, supporting requirements for the calculations of the supporting system, yes, you can use it to design more accurate your supporting systems. However, neither BN or EN is not referring to these standards. So whatever you test, you will get it with slightly changes of the system.
True. Actually, the idea of this is to standard. It is not related to the fair property. Actually, it's not assessing at all the fair property. It is just the basic concept of designing of the fair ductwork system. So it is just to help designing the system, and this is system it need to be tested and verified through the fair test. So that's why it is not supporting the fair property requirement. Either it just only gives the guideline to select and to design the system, either the ductwork system or the supporting system.
So this question need to be listen carefully. It's a bit long question. Suppose there are two manufacturers, one tested with rock wool and other with ceramic wrap insulation. Both got 120-minute insulation rating. As both insulation are approved, can the contractor use duct from one and insulation from the other, or he has to stick to what system is tested for?
So this question was already answered by Hassan previously. If you do the test of this duct with insulation, you are doing the system of the duct system test. You are testing the system, not the particular components, as I said before. Which means, as Hassan said, you stick to what is the design of the duct system.
Yeah.
Hassan, you can.
Yeah, that's right. That's true. And also the idea of this one is not same like to strict with one kind of duct construction, but really, if we will be reviewing the test result coming from different construction with different insulation, we can see the effect of changing the component of the system. So any change of the component of the system, it may affect either negatively or positively for the fair performance of the complete system. So to compare just the same rate to different construction system with different component, it's not fair just to have an general statement. It should be equal and it is interchangeability between both the duct insulation.
Okay, Mrinal, if you are listening to me, there's one question regarding testing in India.
Okay.
At
Yeah.
this point in time, are there any certified labs to undertake BS 47624 testing in India? Do there any testing lab does in
As
India?
as far as my understanding and knowledge is concerned, there are no labs which can undertake duct testing as per this standard in India.
So there is no lab test as per BS
No,
476.
no, no.
Uh, okay. Subhaya is asking how the insurance agency view these protection system while evaluating the premium for any building. Again, for Mrinal, do we really get some premium in case you follow these standards?
Nothing has come to our knowledge so far that any building management company or a property management company has approached us asking for this. So honestly, our view in this particular domain is slightly limited. Yeah,
Okay.
we know for facades they definitely do.
Yeah.
They do get involved, but for ducts, I don't know if Daniel, if have you ever encountered in your previous experience that insurance companies getting involved?
Yes, in these times which we have nowadays, insurance companies are focusing much more into the fire and participating much more into the fire safety of the buildings. And sometimes the regulation of the country which you are looking for the market, for example, will be quite less. However, insurance company can have their own requirements, which means if you want to get insurance for your building, you need to work with their scheme. Which means, for example, there will be no requirements for the leakage. For the ducts. However, the insurance company will say no. We need to have the leakage as well. So you already know that BS doesn't define this leakage. You will not get this leakage. The only way to go is with EN standard. So yes, insurance company are more active from day to day, and nowadays, especially in Europe, they are providing even much more stronger regulations, much more stronger compliance requirements for the building, not for the product. This is very important because this is the build. These requirements are for the building or other bigger part of the system, not for the particular sub products like ducts, dampers, or doors. So if the owner of the building wants to get the insurance, he needs to follow some guidelines, and one of the guidelines might be, for example, that if it comes to the ducts, it must be fire rated, but also with rating of the leakage. So yes,
Okay.
the answer is yes.
Thanks, Daniel. The message to anonymous attendee, you don't have name here. It says anonymous. You have put a lot of questions. So I would say I'll take one question, but we have put Mrinal's mail ID in the chat box. So I
Yeah.
would urge you to write to Mrinal on all these questions. But I will take the one question that may be interested. What is the criteria or application or scenario which defines whether the duct should be 2 hour or 4 hour fire rated?
There is no criteria. This is requirements of the building or the contractors or on the consultant or the regulators, which means, for example, the government. that defines that this compartment must be 2 hours or 4 hours. This is the requirements, not the criteria. However, I saw in the questions, if I may, Dominic, spend 1 minute additionally. There was a question about fire-rated duct, which was tested under 400 degrees.
I was also looking at the same question.
Yeah. So as I discussed this, because I answered already this in my presentation, 400 degrees, neither BS or EN is not referring. BS is referring only to ISO curve, which is the standard time temperature curve, so-called cellulose curve. And this curve after 90 minutes is more than 1000 degrees. You can have low temperature fire rated duct name legally based on EN test after testing the smoke ducts under EN 1366 part 9, but the temperature inside the furnace will not be 400 but 600, because this temperature is defined as the temperature of the flashover. So you can have a low temperature, but you will be limited that, first of all, this will be not 400 but 600, and there will be limitation to the application because these ducts are defined as per EN classification as a single compartment ducts. Means the duct serves only one compartment and remove the smoke directly outside the building. It cannot be used within the duct, within the building, crossing other compartments. One compartment directly outside the building.
That's right. And if I may add also in this point, actually the concept of 400 is coming from the classification for the smoke control fans, which is limited with 400. But the idea here, the fans itself, it will be outside of the fire zone. Normally, it will be in the roof or outside of the buildings. So it will not be directly affected with the temperature or the fire direct, same like the duct. So that's why the duct to be performed during the fire, it need to be protected for all the full fire temperature curve, not limited with 400. But when the limit is it's coming for 400, just this is will affect the smoke control fans only.
Okay, I have two gentlemen who raised a hand. I'll take Abasaheb Khale, who's a well-known risk consultant in India. He's from Mumbai. So, Abasaheb, you can ask the question that you wanted.
Hey, thanks, Dominic. It was just a comment on the last insurance discussion.
Yeah.
See, basically, uh, insurance companies follow a typical way of risk audits, and there are specialized risk auditors who are deployed on the sites or during the greenfield projects or brownfield projects, wherein the specific recommendations are given to client based on the loss experience of these companies, and they have their define their own philosophy. So FM Global, being insurance company, has their own philosophy. Some of the companies follow them and some of the companies follow their own philosophies. It ultimately evolves around quality of risk. So one needs to go through the recommendations given by risk auditors and adopt those basically practices for ducts or anything else. I think mostly they go in line with the local standards, but sometimes they go on and above local standards. Just that's what I wanted to clarify.
Thank you, Abu Sahib. Thank you for clarification. Thanks for pitching in some valuable points here. I'll take the next interaction. Mohammad Radwan, you can go ahead and put your question. Mohammad, are you there? Okay.
Mohammed, you're on mute.
Yeah, Mohammed, can you unmute and speak? Okay, I will. I think by mistake probably he has come. Okay, thank you, ladies and gentlemen. We have exactly 2 hours we have taken for this webinar. Ideally, one subject, would have been good, but it's so interesting, and I'm so surprised that all the attendees stayed back listening to Daniel and Hassan. And this video will be made available to all those people who attended to review again and listen to this. And as I said, ESL, one of the largest testing lab in the Asia, are open for discussion with any manufacturer from India. And we from Bologna support CSL, and we assist them to connect with the right people. So if anybody has any queries, either you can write to me or write to Mrina. We will assist you and take it forward. So we will come back and declare the next topic and subject for the next month. In the month of September, we will come back on again on the pacifier product. So till then, stay safe. Look forward to see you. Have a wonderful weekend. Thank you. Bye bye. Thank you, Rinal. Thank you, Daniel. Thank you,
Dominic.
Mohammed.
Thank you.
Thank you.
Thank you.
Thank you, Arya, for supporting from back end. Thank you.